These problems, we're talking about end behavior going to, as x goes to infinity or negative infinity. So when you're talking about end behavior, so not middle behavior, end behavior, you want to look at which piece in your numerator and which piece in your denominator is the quote unquote winner. So which one is steepest? Which one is going to go off to infinity or negative infinity kind of the quickest? Like which makes the most difference? So for example, ln x log graphs look like this. Negative 4x cubed, that's going to like be pretty steep. It's going to look like this. And then 5x looks like this. Okay, so this graph, as x goes to infinity, this one is the winner because it is the steepest. It's going off to negative infinity faster than these are going to infinity. So usually it's the order that you want to look at for infinity is exponentials, then highest power, and then square roots and logs, and et cetera, et cetera. But logs do not go to infinity fast at all because they are the inverse of exponentials, and exponentials do go to infinity fairly quickly. So this limit is the same as this limit. And again, use proper limit notation. And then, okay, when we're comparing sine and cosine, well, sine oscillates between 1 and negative 1. So that definitely is not our winner. So it's going to be 2x cubed. And then, okay, well, what's negative 4x cubed over 2x cubed? That's negative 2. So what this tells me is that on the right-hand side, this function, this very complicated function on the right-hand side is going to have a horizontal asymptote of negative 2. For this next one here, we have e to the x minus x to the fifth plus x. So again, highest power versus exponential. An exponential function, as long as it has a base larger than 1, so this is exponential growth, exponential functions are always going to be our quote-unquote winners. So limit as x approaches infinity is going to be e to the x over, and then looking at our denominator, square root doesn't go to infinity very quickly, so that's going to be x to the 10th is our winner. Okay, now this one isn't like the previous one where we could just divide them. Here we have e to the x over x to the 10th. So again, now we're comparing to see what our quote-unquote winner is. E to the x, our exponential, is still going to beat, quote-unquote, beat x to the 10th. So our numerator is going to infinity faster than our denominator. So our numerator might be like 100 billion, and our denominator might be like 10,000. Well, 100 billion divided by 10,000 is still a really big number. So if your numerator, quote unquote, wins against the denominator, just look at what your numerator is. It's going to infinity because whatever this is going to win over this one. Now, if your denominator were to win, so let's talk about that situation. Here I have the limit as x approaches negative infinity. Okay, now, again, normally exponential growth is the winner. But if you plug in negative infinity, that's going to be e1 over e to the infinity. That goes to 0. So exponential decay goes to 0. So here, the exponential function is not the winner because it would approach 0. So negative x to the 5th is our winner. And always keep your coefficients. And then here we have x to the 10th, negative x to the 6th, square root. So x to the 10th is still our winner. Okay, now our numerator is smaller than our denominator. If your denominator is the winner, so x to the 10th, so like, again, that could be like 100 billion where our numerator is only 10,000. Well, 10,000 divided by 100 billion, that's not actually what happens, but just bear with me. Your numerator might be a big number, but if your denominator is so much bigger, then your limit is going to approach 0 because your denominator is the winner. Your denominator is huge. If you take a small number and divide it by a really large number, that's going to approach 0. And then lastly, this is always a fun one. So here, this is the same limit as this. 2x cubed over the square root of 16x to the 6th. And then you might say, okay, well, the square root of 16x to the 6th, that is 4x cubed. And then I get 1/2, right? But here's the thing. because we started with a square root, my denominator is always positive. If you plug in a negative number into x cubed, that's negative. But because I have a square root in my denominator, that's got to be positive always. Okay, so my answer is actually not 1/2. So let's see what happens if we plug in negative infinity. So think of it like this. Okay, I'm going to do kind of like fake math here just to illustrate a point. 2 times negative infinity cubed over 4 times absolute value of infinity. So negative infinity, if I plug that in, I should get a positive number, because remember, if I have a square root to begin with, my denominator better be positive. Okay, and then that becomes negative 2 infinity cubed over 4 infinity cubed. And that is actually negative 1/2. So what I want you to consider is, again, what is the value if you plug in negative infinity into this entire beginning function? So yes, my numerator goes to negative 2 times infinity cubed. My denominator goes to positive 4 infinity cubed. So if I plug in negative infinity, what I actually get is negative 1/2. So you can go ahead and like simplify the 1 out, because adding 1 to infinity doesn't really change the behavior. But then when you're looking at this function here, compare if you plug in negative infinity, your numerator is negative, but your denominator is still positive. So if you need to, you can simplify the square root of 16 x to the 6. You can make that an absolute value, because again, it must be a positive number, and then you can kind of compare. Or you can like kind of look at this original function to figure it out. But the answer is negative 1/2, not positive 1/2. So I just want you to be careful if you have square roots, or even if it was just an absolute value, just pay attention to like, oh, my numerator is negative, or my denominator is positive, so my answer must be negative, or vice versa, whatever it is.